Hello and welcome back to Techlearners. Today we will understand what we mean by equivalence relation. Equivalence relation. In the previous lesson, we had seen the properties of the relations, like what is a reflexive relation, what is a symmetric relation, what is a transitive relation, what is a non-transitive relation. So today we will understand what we mean by equivalence relation. So let us define this equivalence relation. Let a relation R, let a relation R defined on a set A, defined on a set A such that it follows following three properties, such that it follows following three properties. So property number one, it is reflexive, which means R has to be reflexive. So we have already seen what is a reflexive relation, which means for all x that belongs to set A, x R x is true. So this is reflexive. The second condition, that relation must be symmetric. We have already seen the definition of a symmetric relation with the examples as well. So this means for two elements, that is x and y, belonging to set A, if x is related to y, then y should also relate to x. This is the symmetric relation. And the third condition, which should also be true, that is, it should be transitive. So we have already seen the definition of a transitive relation. Let's see what we mean by a transitive relation, which means for any three elements, let's say x, y, and z that belongs to set A, if x is related to y and y is also related to z, then this should imply that x is also related to z. So any relation which follows these three conditions, one is it is reflexive, other is it is symmetric, and it is also transitive, then we say that this is equivalence relation. Now let us see an example on this. Let us say that there is a set A with elements 1, 2, and 3. And a relation R is defined on this set A, means from A to A, such that this relation R has ordered pair x comma y when x is less than equal to y or y is less than equal to x, when x and y belongs to set A. So this is the definition of the relation. Now we have to check whether this R is equivalence relation or not. So whether this R is equivalence relation or not. So we will see, we will check this R for all these three conditions. So let's see, before we check whether this R is reflexive, symmetric, and transitive, let's create the relation R, that what ordered pairs we will have in this relation R. So the set is A, so we'll start from A. The first ordered pair will be 1 comma 1. So it is from A to A, so it is 1 comma 1. This is first order pair. The second order pair, 1 will relate to 2 as 1 is less than 2. So we will have 1 comma 2. The third order pair will be 1 comma 3 as 1 is less than 3. So this is 1 comma 3. Then we'll take this element 2 and we'll see whether this 2 is related with 1. Yes, 2 will relate to 1 as 2 is, so we can have 2 comma 1. We can see just like this y is lesser than x. So this the second condition, it is following the second condition. Then we will also have 2 comma 2 as both are equal. So we can see the equality condition is in both of the conditions. And then we'll have a 2 comma 3 as well, as 2 is less than 3 following this condition. Now let's take the third element, which is 3. So 3 comma 1 will be there, yes, because 1 is lesser than 3 following this second condition. Similarly, 3 comma 2 will also be here because we see that 3 is this is 2 is less than 3, as this is following the second condition. And finally 3 comma 3 will also be there, as both are equal to each other. So this is the relation R we are talking about, which has been defined. Now let us see whether this R is reflexive or not. For R to be reflexive, we need that for all x belonging to set A, x R x must be true. So we can see here the first element is 1, so we have 1 comma 1 in the relation. The second element is 2, and we have this 2 comma 2 in the relation. And the third element is 3, for which we have 3 comma 3 in the relation. So we say that R is reflexive. So hence this R is reflexive, right? And we also know that each element is equal to itself. So in this case, x r x is definitely true. So we have already seen that this R is reflexive. Now let's see whether this is symmetric or not. So we know for any two elements x comma y that are belonging to A, if x is related to y, then y should also relate to x. Let's check this for all the ordered pairs that are available in this. So we'll start with this 1 comma 1. Okay, so for 1 comma 1, we know this is 1 is related with 1, which means 1 should also relate with 1. This is yes, 1 comma 1 is here. So next is 1 comma 2. So for 1 comma 2, what we should have 2 related to 1. So we can see this 2 is related to 1. So these two are symmetric to each other. That's also true. Next is 1 comma 3. So for 1 comma 3, we should also have 3 related to 1. So we can see this is 1 comma 3, and here we have 3 comma 1. So this is also true. Next is 2 comma 2. Definitely for 2 comma 2, we have 2 comma 2. Next ordered pair is 2 comma 3. So we see that for 2 comma 3, we are also having this 3 comma 2, right? So this will relate to 2 is related to 3. Then what we should have? We should have 3 related to 2. So this is also true in our relation. And last ordered pair is 3 comma 3. So we have seen that for all the ordered pairs that are available in R, uh, if x are y, then y are x is also true. Hence, what we'll say that this R is symmetric. So hence we say that R is symmetric. Okay, now let's see whether this R is transitive or not. So the third condition, R being a transitive element, what we need to have for any three elements, let's say x, y, z, that are belonging to A. If x is related to y and y is related to z, what should be the resultant? That x should relate to z. For that, we need to frame conditions. For let me rewrite this relation R here again, so that we can frame the conditions. So we have 1 comma 1, 1 comma 2, 1 comma 3. We have 2 comma 1, 2 comma 2. I'm just copying it from the above. 2 comma 3, and then we have 3 comma 1, 3 comma 2, and we also have 3 comma 3. So this is the relation. So let us start with first ordered pair, which is 1 comma 1. Okay, so for 1 comma 1, what should we find? Let's say for 1 comma 1, we have 1 comma 2, and these two together will should have we should have 1 comma 2. Okay, so together we should have 1 comma 2. This is the condition of, let me write and here. So this is the condition of transitivity, which is true for first pair. Then again, let's pick 1 comma 1, and now we should have for 1 comma 3, resultant should be 1 comma 3, which is in our relation. So this is also true. So for 1 comma 1, we have only these two conditions. The next is 1 comma 2. We'll start with 1 comma 2 now. For 1 comma 2, we have this 2 comma 1. So this is 2 comma 1. The resultant should be 1 comma 1, which is in the relation. Next is for 1 comma 2, we have 2 comma 2. And then again, the resultant should be 1 comma 2, which is we are having in the relation. And the third condition with 1 comma 2, we should have uh, and 1 comma 2 will have 2 comma 3. The resultant should be 1 comma 3, which is already in our relation. So we can see for this 1 comma 2 ordered pair, the condition satisfied. Next is let's pick this element 1 comma 3. So 1 comma 3. What are the initial conditions? For 1 comma 3, we have 1 as 3 comma 1. For 1 comma 3, we will have 3 comma 2, and for 1 comma 3 we have 3 comma 3. Resultant of this is 1 comma 1, which is there. Resultant of this is 1 comma 2, which is also there, and resultant of this is 1 comma 3, which is also there. So uh, for this also we have all the transitive conditions true. And similarly, we can see for any two pair, if x are y and for y are x, we can check it for this in this case, and we will see that for all conditions, this relation will hold the transitivity. As we all know, because the condition is either x should be less than equal to y or y should be less than equal to x. So in this case, if our x is related to y, if x is related to y and y is related to x. So we can have only few conditions like x is less than y is less than z. It should be z, y is less than z. So ultimately we will have x related to z. Either x will be less than z or x will be equal to z or x will be greater than z. So this is a transitive relation as well. So we will write hence R is transitive. So as we can see from all those three conditions, we conclude that R is reflexive, R is symmetric, and R is transitive, and hence the given relation R is equivalence relation. So we'll say that this is true, R is an equivalence relation.